Hi all, welcome to my YouTube channel Know About Embedded System. In this video, I'll show you how to generate sawtooth waveform, nothing but a ramp wave and triangle wave. How to generate triangular wave and ramp wave generation. So both are similar, triangle and ramp wave, with there is a slight difference. Let us see how to generate that using DAC. So if you are not subscribed my channel, please do subscribe. And let us start the video here. So how to generate the ramp wave or a triangular wave? So you know that already. So binary inputs I have to give to the DAC, and DAC will produce output, analog output. So when I say there are two things I need to explain here. One is a ramp wave, or you can also say sawtooth waveform. Sometimes it's also called as sawtooth. So if you want to generate a ramp wave, and on the other hand, I will explain how to generate the triangle wave. Triangle wave. So if you want to generate the ramp wave, it's very simple. Just you have to go on incrementing the wave. So this is your ramp wave. Ramp wave means just you need to go on incrementing. Okay, so just you go on incrementing, and when it reaches to FF value, come back to 0. So like this, you can generate ramp wave. It's also called as sawtooth waveform. So it starts from 0. Let us keep in mind it starts from 0 and it will go up to FF with increment of one value, and when it reaches with 0, let us come back to 0. When it reaches with a maximum value, that is FF, so you need to come back to 0. Again, go on incrementing and come back to 0. Go on incrementing and come back to 0. So this is how you can generate ramp wave generation, or it's also called as sawtooth waveform generation. Okay, so in case of triangle waveform, here in the bottom I'll write for a triangle waveform, same procedure. We have to use for loop. Here you can use a for loop here, or you can also use a while loop. Use for loop. Using for loop, you can generate positive ramp to generate the ramp wave or sawtooth waveform. For the triangular waveform generation, for a triangle waveform generation, same procedure we have to repeat for incrementing and decrementing. So one loop I'll use for incrementing and one more loop I'll use for decrementing. So I had to use two loops, one for incrementing and one for decrementing. So in this way I can generate triangle waveform and ramp waveform. It's very easy. Just we have to use one for loop for a ramp wave and one more for loop for triangle waveform generation by using DAC. I hope this logic is clear to all. So let us go back to the code and let us develop the code, and we will check the output in the debug window. So let's go back to software. Okay, so in the software, yeah, you can see it's again I have already written the code. Very simple. As you know that this is for function selection for analog output, and here you can see I'm using one simple for loop. So simple for loop I'm using I starts from 0 and I less than 255 and I plus plus, and DAC input I'm multiplying I with 4. You know that why I'm multiplying by 4, because to convert that into 10 bits, because 255 up to 255 it's 8 bit and I need to give input up to 10 bit. That's why I'm multiplying by 4. And that DAC input value I'm assigning to DAC control register. That stands for the digital to analog converter control register. Okay, just you assign. Initially it will start from 0 and it will go on 1 to up to 255, and when it reaches to 255 again we will start from 0. So this code is for ramp wave generation, or you can also say that it's a sawtooth waveform generation. This is for sawtooth or positive ramp wave generation. Now let us compile this and we will check the output. Okay, go to the debug window. So as you know that, so this is a logical analyzer. I have already shown you how to generate, how to set up this logical analyzer. Just you can give the, yeah, this is called as positive ramp. positive ramp waveform, since it is starting from 0 and going to FF and again coming back to 0. So this is generating continuously. It is not stopping. Since we kept it in an infinite loop, it is able to generate continuously. Okay, so this is called as positive ramp. It is also called as Sawtooth waveform. Now let us do the small changes in the core and we will generate final triangular waveform. Okay, for the triangular waveform generation, same code we have to do it, and we have to decrement it as I already told. So we have to use two for loop, one for loop for incrementing and one more for loop for decrementing. So we have to use two for loop. So this upper for loop is for incrementing and the lower for loop, that is for decrementing. Let us start from 255 and let us go with the, if it is greater than 0 and I minus minus. Very simple for loop we have to use. Let us start from 255. Okay, and then it should be greater than 0 and then you can just decrement once. That's it. So the upper part is for positive ramp and the lower part for negative ramp. So when you both put it together, it will behave like a triangular waveform. So let us check whether will it able to generate triangular waveform. So let us go here. Yeah, so keep analyzer here. Now you can see. So we're having two outputs. One waveform is generating, one for loop is generating one wave, that is nothing but positive ramp, and a negative ramp is generated by one more for loop. Right. So in this way we can able to generate triangle waveform and ramp waveform using DAC again. So please click on like button and subscribe my channel to know more about embedded system. So I'll come up with the next video. Till then, keep on watching my channel, know about embedded system.